What matters more now? Reaching the edge first, or making that edge easier for everyone else to also reach? Moonshot, a Chinese lab with roughly 300 people, has released a downloadable model with nearly 3 trillion parameters. It's a tremendous leap forward in open models compared to closed. But in the same news cycle, the National Science Foundation moved to block nearly all the research that it funds with Chinese researchers. One side of that contrast understands how discovery now builds on itself. The other side is trying to contain a process that moves faster when it moves freely. So here's the claim I'll stand behind. The frontier now advances when ideas circulate. Every attempt to hold knowledge still makes the holder slower. Come with me, let's get into it. Moonshot AI released Kimi K3 on July 16th. Moonshot is a Chinese lab with roughly 300 people. Kimi K3 is a 2.8 trillion parameter open-weight mixture of experts model. That mixture of experts design shapes how it runs. Only part of the model activates for each token. That gives K3 an enormous total capacity while keeping each individual response practical to run. The model can process 1 million tokens of context. It also has native vision, and the weights are open to be released here in a few days. Anyone will be able to download the trained model file and run it on their own hardware, assuming sufficient compute, by July 27th. K3 is already live through Kimi's website, Kimi Work, Kimi Code, and an API. Its benchmark results put it very close to the top of the field. In blind arena testing, K3 ranked first for web interface engineering, and it ranked second overall, behind only Anthropic's closed Fable 5. Simon Willison independently tested the model, and he found that K3 beat Opus 4.8 Max and GPT 5.5 High across most tasks in his test set. It still lost to Fable 5 and OpenAI's GPT 5.6 Sol. But stay with that difference. K3 sits in the spot directly behind the strongest closed model, just short of the overall lead. Artificial analysis gave K3 an ELO score of 1,547, and that is a jump of more than 700 points from its predecessor, K2.6. And it also won outright on Program Bench, SWE Marathon, Spreadsheet Bench 2, and Browse Comp. Then we get to the result that changes the shape of this story. On Kernel Bench Hard, K3 matched Fable 5 on GPU-kernel optimization, and it substantially outperformed Opus 4.8. A GPU kernel is a low-level code that tells a chip exactly how to perform a computation, and better kernels get more useful work from the same hardware. So think about what that creates. Training AI requires enormous amounts of computation. A model that improves GPU kernels can make that work cheaper and faster. The intelligence running on the chips can now help the machinery underneath it run better. That is a recursive loop with a physical payoff. K3 also gets credit for autonomously designing a chip. That claim needs the same independent scrutiny, of course, as any other reported result in autonomous engineering. Even if we take the narrowest view, the kernel result already shows that a model can make the hardware running it more efficient. Compute remains one of the strongest ways that large institutions try to keep an advantage. Training at the frontier demands chips, energy, and capital. K3 attacks that constraint from inside the workload itself. But the model is also expensive by Chinese AI standards. Moonshot charges $3 per million input tokens and $15 per million output tokens, so it's among the most expensive models that a Chinese lab has shipped. K3 also uses about 1/5 fewer output tokens per task, and that brings its estimated effective task cost below $1. So, Moonshot is pricing the model around the power that it believes it has delivered rather than leaning on cheap access to win attention. The market reacted immediately. Shares in rival Chinese labs GPU and Minimax fell 27% and 16% on release. Those drops don't prove that either company has lost its technical position, but they show how quickly a new model can shake the belief that any lab's lead will hold for any substantive amount of time. The larger trend has been building over recent days here. The Chinese open-weight models recently reached 41% of Hugging Face downloads, as we covered here on Century Report. They also claimed OpenRouter's top 6 positions. Then, Thinking Machines Lab released Inkling from the American side of the open ecosystem, and now Moonshot has put an open model in second place overall, directly behind the strongest closed proprietary system. Open weights don't make the physical cost of running a model just disappear, obviously. A model this large still requires serious hardware, but what they change is who gets to inspect it, adapt it, test it, and build from it. The model's power can leave the company that trained it. And K3 adds another powerful wrinkle. What leaves the lab may help lower the cost of running whatever comes next. The trained intelligence becomes shared infrastructure, and then it starts improving the infrastructure under itself. Okay, shifting to another story here. As agents grow more capable, they're creating friction inside real organizations. 3 VentureBeat pulse surveys came out on July 16th. They found that companies are giving AI agents more freedom than their evaluation and security systems can reliably govern. Now, an agent, as you know, is more than just an assistant answering a question. It has access to production systems. It may hold things like credentials, call tools, and retrieve company data and take actions. The first survey covered 157 organizations. Half had already shipped an agent that passed every internal test, but then failed when it reached a real customer. Only one organization in 20 said that it fully trusts the way automated systems judge agents. Yet roughly 2/3 already allow agents to work without a human in the loop, or are building toward that point. And that is a startling mismatch. Companies are preparing to let automated tests approve changes to agents. Most of those companies don't fully trust the tests that would give that approval. So the security survey found the same gap from another angle as well. Among 107 teams, more than half had confirmed an agent security incident or near miss, yet only about a third gave every agent its own scoped identity. Now, a scoped identity means that each agent gets limited credentials only for its own specific job. So if that agent fails, it can do damage only near the task that the team gave it. Many organizations still let several agents share credentials across those scopes, so the incident numbers show what that choice costs. Teams whose agents share credentials reported incidents at about 64%, but teams that gave each agent its own scoped identity reported about 41%. So that doesn't reveal every cause behind every incident, but it does give companies something that they can change and that they can measure. Give each agent its own identity, limit what that identity can reach, and revoke it without disrupting everything else. Only 30% of teams put their highest risk agents in sandboxes. Now, a sandbox isolates the agents so that a failure cannot spread freely through the wider system. Among the security products measured, OpenAI's guardrails have reached the most teams at just over half. Now, guardrails still come after basic care in how teams just run their systems. A safety layer cannot make a shared master credential a good idea. The third survey looked at context. Of 101 teams, 57% traced their most damaging, confident but wrong answers to bad retrieval instead of the underlying model itself. Now, retrieval is how the agent goes out and finds the material it needs before answering. The system may retrieve the wrong document from the RAG database. It may have an outdated policy that it prioritized over one that is more current, or maybe there's an irrelevant customer record. The model often doesn't know the difference, which leaves it incumbent on the humans to actually make the data readable and ingestible and properly parsable for the model. So the model may reason competency over bad evidence, for example. The answer can sound polished because the reasoning itself worked, but the starting material itself did not. So that finding changes the fix. Teams can choose better documents and tighten who can access them. They can also keep those documents fresh and track where they came from. Just swapping the model will leave the real failure untouched. This is one of many hard lessons that institutions are learning, but the more we learn them, the better these agents get for automating and improving our overall capabilities. Tools built into the provider's own systems have now overtaken standalone vector databases as the main way to ground answers. And OpenAI file search reached 40% adoption in this survey. Google Vertex followed really close behind. All 3 surveys point to the same lesson. Teams need more care when they put agents to work. Agents are entering production. The systems around identity, isolation, retrieval, and testing have not kept pace. That creates incidents, and it also creates evidence. Companies are now pooling failures that they might once have kept hidden inside their own walls. We can see which credential pattern lines up with the more incidents. AI is forcing more openness among previously closed systems. We can tell a model failure from a retrieval failure, for example. We can compare what an internal test says with what a customer said they experienced. Those comparisons are creating a layer of accountability while the system is under load, one that would not have existed were it not for AI agents. The technology can act. The system around it is learning how to decide what it may touch and what evidence it should trust. It's also learning when a human needs to step in. And again, it's also forcing bridges between companies learning how this stuff works when there used to be walls. Okay, now we've seen systems learn where agents need boundaries, but now medicine is removing a boundary that patients have faced for years. On Thursday, July 16th, the Food and Drug Administration approved Merck's Lipfendra. It's the first FDA-approved oral PCSK9 inhibitor, and it can lower LDL by an amount comparable to PCSK9 therapies that previously came only as injections. Now, LDL is the artery-clogging cholesterol that aggressive prevention tries to drive down. Statins remains the standard oral treatment. For many patients, though, statins can lower LDL only so far. The most powerful therapies have been PCSK9 inhibitors, and until now, patients needed an injection to lower LDL that much. Lipfendra brings that power into a pill. One cardiologist quoted in the reporting called it a game changer. The strongest reason for that enthusiasm is how many more people can now use it. Many patients need to lower their LDL more than statins can, and many have hesitation to use an injectable drug. A therapy can work beautifully in a trial, but if people decline to take it, it simply can't help the wider population. That gap matters enormously here. Heart disease remains the leading cause of death in the United States. Now, back in March, we actually tracked here on the Century Report the phase 3 data on the oral PCSK9 inhibitor enlicitide. The data showed that it could lower LDL as much as injectable treatments. The FDA approval turns that clinical result into a treatment people can really soon get. AstraZeneca is developing a competing oral cholesterol drug as well. Competition in medicine is good. 2 programs are aiming for the same goal. That suggests patients may soon have more ways to control LDL with a potent drug they can simply swallow. The approval starts the next stage. Physicians still have to prescribe the drug broadly, of course. Insurers still have to cover it. Data from real-world use has to show that patients keep taking it and get the expected benefit. But still, the core barrier has changed here. Medicine already knew how to lower LDL this aggressively, but the breakthrough is putting that power into a form that people can simply take every morning. Okay, that same question about access appears at a completely different scale when we move over to energy. Who builds the infrastructure that a new technology requires and who pays for it? Google announced on Tuesday, July 14th, that it will take 2 roles in the first 2 phases of the Steel River Energy Center in Arkansas. It will serve as anchor investor and buy the energy. Now, the project has broken ground, and it will combine 2.5 gigawatts of solar power with 2.9 gigawatt hours of battery storage. It will be the largest solar plus storage project in the United States. Solar plus storage pairs power generated during the day with batteries that can deliver it after the sun goes down. That pairing matters, of course, for data centers because they want electricity around the clock. Google's 2 roles here are important. As an anchor investor, it helps to pay to build the actual project. And as an off-taker, it promises to buy the energy that the project itself produces. And that promise helps the project get financing. Developers and lenders know a large customer is waiting on the other side, so of course they work on the project. Google may describe the deal through its preferred clean energy framing, but the basic move is actually simpler. The company is helping pay for new power as its demand grows. AI data centers are colliding with a grid built for slower growth. The fight across the country now centers on who pays. Should ratepayers cover the cost of new power plants and transmission lines? Should the data centers creating the new load pay for that infrastructure themselves? Federal regulators and the PJM power market have recently pushed more of that duty toward the large loads, as we've been covering here very frequently on Century Report. Data centers face new rules to keep the grid reliable, and PJM stakeholders have approved a backstop that uses long-term contracts to pay for new power. Steel River shows a company making a similar move through its own investment. Google needs enormous amounts of compute, obviously, and here it's responding by helping pay for new clean power instead of treating the existing grid as just an unlimited supply. The project doesn't answer every question about how much electricity the data centers use, but it does show a structure that could work. The company that needs the power helps to build it. The company also promises to buy that electricity, which helps the project get the financing. Solar and storage grow together. That structure can move faster than waiting for a strained grid to take on every new load and pass the bill to everybody else. The economics are changing here. Companies increasingly need to absorb the cost of energy if they want to secure that energy at all. Now we reach the sharpest conflict of the day. Companies and researchers are learning how much their progress depends on infrastructure that they share. Meanwhile, the National Science Foundation is moving in the opposite direction. New restrictions would ban most collaborations between scientists in the United States and China when the NSF funds that work. The move came on July 16th. The NSF is the main federal agency that supports non-medical basic research in the United States. If NSF money helps fund a project, then researchers would now face a broad ban on working with Chinese counterparts. The relationship behind that fence has produced an outsized share of the world's most cited research. That work spans material science, clean energy, climate modeling, and the life sciences. Those fields deal with problems that ignore national borders. Client systems cross borders. Energy transitions depend on global manufacturing and shared physical knowledge. Life science moves forward when researchers can compare populations and organisms and datasets and methods. Now, of course, we need to treat the national security tension honestly. Some research transfers sensitive capabilities. Governments have legitimate reasons to protect narrowly strategic work, but we shouldn't automatically treat a basic discovery the same way that we treat a military capability that someone can directly and immediately apply. But that is exactly why the near total scope of this is so troubling. A blanket restriction treats almost the entire scientific relationship as strategically sensitive. Much of that work is ordinary, pre-competitive research. It creates the basic knowledge that companies and governments later turn into products. Researchers will pay the immediate cost here. Scientists on both sides will lose collaborators. They will lose access to datasets. They will lose informal exchanges that let someone challenge or correct an early idea. And those conversations can also connect an idea to another field entirely where the benefit can be equally felt. With this move, careers are going to become much harder. Teams are going to repeat work that collaborators could have simply shared. And there's an even deeper problem, which is that the policy relies on a weak idea of how knowledge even moves. When scientists publish a result in one country, it becomes a foundation in every country. When one laboratory demonstrates a technique, it can spread before institutions finish writing rules around it. As we have seen over and over again with AI, an organization can try to train a model behind its own walls, but within months, its weights can appear in the open. Exactly as we saw with Kimi K3. So restricting who works together may slow the researchers under the rule, although that's very arguable, but it won't stop the knowledge itself from moving through papers, models, repeated experiments, and separate discoveries. That makes this a blunt and self-defeating response to what is unfortunately real geopolitical tension. It assumes that scientists working together create a liability. Yet humanity needs more people working together on common problems, and the timing makes the contradiction impossible to miss. The same week that the NSF moved to put a wall around US-China research, a Chinese lab with roughly 300 people released Kimi K3. And by July 27th, anyone on Earth will be able to download its full weights. The policy imagines that geography can contain powerful knowledge and technology. The model shows how quickly that power escapes geography now. This doesn't mean that every joint project should move ahead without any safeguards at all, but it does mean that safeguards need to protect work that's truly sensitive while allowing people to share the basic discoveries. A near-total ban gives up that care and precision. It weakens the everyday human connections that help scientists catch errors, share methods, and build the knowledge together. Meanwhile, the information itself will keep moving. The wall delays the people distracted by building it far more than it does anybody else. Discovery will continue around them. All right, let's bring it to a close for today. A frontier you can own sounds like a line that you can draw on a map. If you cross it first, you plant something there, and you defend that ground. But today's frontier behaves more like a chain reaction. Kimi K3 improves the low-level code that helps chips perform more computation. Better compute supports the next generation of models. Enterprise agents fail in production. Organizations combine what they have learned, and then they see how they need to change identity, retrieval, and testing. Separately, a powerful cholesterol therapy is moving into a pill, and that means more people may now be able to accept the medicine that they already knew helped them. A vast solar project can now get financing because the company creating the new demand commits its own money and promises to buy the power. In each case, progress comes when more people can use what a technology can do. Then the NSF restriction shows the opposing instinct. Draw a perimeter, break the relationship, treat shared knowledge as something that you lose when another person gains it. Science does not work that way. Intelligence does not work that way either. You can copy or benefit from knowledge without taking it away, supposedly, from the person who had it first, whatever that means. Working together adds new experiments, criticism, data, and perspective. The next person can make what everyone has even bigger. That's why the most important feature of Kimi K3 goes far beyond any benchmark score. The model can circulate. Its weights can move into laboratories, companies, and research communities that Moonshot AI does not control. Those people can test it, alter it, and build from it. The frontier now advances when one result becomes the starting material for another. Now, institutions can still try to slow that handoff. They can make careers harder, and they can force people to repeat work. They can keep a temporary advantage by limiting who gets to take part, and all the while try to ignore how much it's hamstringing themselves just as much. But the cost of doing that keeps rising, because everyone outside the wall continues learning. So who holds the frontier now in any field? That answer keeps moving. The frontier sits wherever a new technology can meet the next person, the next problem, the next idea. It doesn't wait for permission from the place where it began. We will build the future by keeping discovery moving. We will build it by making every breakthrough easier, not harder, to carry forward. We'll see you tomorrow.